Hi everyone. In today's video we will understand one of the most important concept in calculus, that is limit, using this graph full of examples. Here we have function fx drawn across different values of x. You will notice that there are some open circles, closed circles, some jumps and some undefined points also. Each of these helps us understand different types of limits. So let's get started. If we see this point x is equal to minus 1, if you look at the graph as x approaches to minus 1 from left hand side, we will see that the function moves towards the value 5. So we can say that left hand limit of x approaches to minus 1 is 5. But if we look at from right hand side, the graph approaches to x is equal to 3. So we can say that right hand limit of minus 1 is 3. So here we can see that both the limits of the graph exist but they are not equal. Therefore we can say that limit as x approaches to minus 1, it does not exist. So this is very important example of jump discontinuity, where the limit of the function exists but they are not equal. Similarly, if we notice some other example of jump discontinuity in this graph, we will see x is equal to 10. Here also, if we see from left hand side, the graph approaches to minus 3 as x approaches to 10. And from right hand side, if we notice, as x approaches to 10, the graph approaches to minus 5. So both the limit of the function exist but they are not equal. So this is also very important example of jump discontinuity. Now next, let's move on to point x is equal to 7. Here if we notice, as x approaches to 7 from left hand side, the graph fx approaches to y is equal to 2. That is limit as x approaches to 7 from left hand side, fx is equal to 2. And if we notice it from right hand side also, the graph approaches to 2 only. That is both right hand limit and left hand limit as x approaches to 7 is 2. But if we notice, there is this open circle which denotes that the actual value of function at x is equal to 7 is not defined. This shows a very important point that a limit can exist even when function's value is missing. These types of discontinuities are known as removable discontinuity. Removable discontinuity. Here, another example of removable discontinuity in this graph is x is equal to 18. Here also, if we notice that x approaches to 18 from left hand side, the value of function becomes 5. That is limit x approaches to 18 from left hand side, the function gives value 5. And if we notice from right hand side also, the function gives value 5. Limit x approaches to 18 from right hand side also is 5. But there is this open circle which denotes that actual value of 18 is not given, not defined at 18. So the limit of the function exists but the actual value of the function is missing at x is equal to 18. Now let's move to this point x is equal to 14. Here if we notice, as x approaches to 14 from left hand side, the value of function goes to infinity, positive infinity. So we can say that limit x approaches to 14 from left hand side, function gives value infinity. And if we notice from right hand side, the value goes down to minus infinity. Limit x approaches to 14 positive, it goes to minus infinity. So here we notice that both the limit, both left hand limit and right hand limit of x is equal to 14 does not exist, right? So let's quickly summarize which all types of limit we have studied in this graph. First, there is jump discontinuity. What is jump discontinuity? When both the limits exist but they are not equal. Like we saw in this graph, the limits, the point marks with blue pen, that is x is equal to -1 and x is equal to 10 were the points of jump discontinuities. X is equal to -1 and x is equal to 10. And next is removable discontinuity, when both the limits exist and are equal but the function's value is not defined at that point. Example of these are x is equal to 7 and x is equal to 18, right? I hope you understood this graph. Thank you so much.